Hello, my dear students. In this video, we will discuss quadratic equations. The definition of quadratic equations, examples of quadratic equations, identifying the parts of a quadratic equation, transforming quadratic equation into standard form, and representing worded problems involving quadratic equations. Before we proceed to our lesson proper, let's have a review of your prerequisite knowledge, which is the multiplication of polynomials for you to fully understand our succeeding topic. So to multiply polynomials, remember that multiply each term of one polynomial by each term of the other polynomial, then simplify by combining similar terms if needed. Okay, let's try number 1. 3x multiplied by 4x minus 5. So in this case, we apply the distributive property of multiplication over addition. So 3x times 4x, you have to multiply the coefficients first. So 3 times 4, which is 12, and the common variables, which is x and x, which have an understood exponents of 1. So x raised to 1 times x raised to 1, you add the exponents, becomes x squared. Then the other term, 3x times negative 5, which is negative 15, and just copy the variable x. Okay, next we proceed to number 2 example. So as you can see, 5x plus 4 is a binomial multiplied by another binomial 4x minus 5. This case is different from the first one because the first one is monomial to be multiplied with a binomial, while the second case, a binomial is to be multiplied by another binomial. Now, if you remember your FOIL method, which stands for first, outer, inner, and last, then that's the method that we are going to apply here. So first terms, 5x times 4x. Again, the coefficients are 5 and 4. So if you multiply them, that's 20. And the variables x times x. So if you multiply them, that's x squared. Next, we go to the outer terms. Oh, outer. So 5x times negative 5 is negative 25x. And we go to the inner terms, 4 times 4x, which is positive 16, and the last terms, 4 times negative 5 is negative 20. Now, as you can see, there are similar terms here, namely negative 25x. Oops, we forgot x on 16. So we put x. So the similar terms are negative 25x and positive 16x. So what are we going to do to simplify them? We combine their numerical coefficients. Okay, so first let's rewrite the first term, 20 x squared. And since we are going to combine negative 25x and positive 16x, you subtract their numerical coefficients because they don't have similar signs. So the dominant number here is 25 because it's larger, so you follow its sign, negative, here negative 9x, and just copy the constant term here, which is negative 20. So negative 20. And that's it. Okay, so we have another example here, which is a square of a binomial. Quantity x plus 6 is squared. So I will show you two methods. The first one is our generic method, which is the FOIL method, and the second one is the short method. Okay, so first I will show you the FOIL method in dealing with this square of binomial. So x plus 6 is squared, or x plus 6 quantity squared. That means x plus 6 is to be multiplied by itself, which is another x plus 6. Applying the FOIL method that we have discussed earlier, so x times x, we have x squared, then outer terms, again, x times 6, so that's 6x. So 6x, and the inner terms, which is 6 times x, so 6x again, and multiply the last terms, which is 6 times 6, which is 36. Then again, by combining similar terms, we could simplify the answer by copy the first term and the middle terms, 6x and another 6x. If you add them, of course, that's 12x plus the last term, the constant term, which is 36. Okay, so this is the answer. Now, for the short method, there is a technique to that. Short method, let's represent it by SM, short method. The short method can be done by squaring the first term, square of the first term, then plus or minus depending upon the operation between the two terms in the binomial. Now in this case, so the operation in our binomial is plus. That's why our operation on our middle term here is the plus sign, plus. Okay, so first term squared plus or minus twice the product of the first term and the last term plus, that's always positive. The last term in squaring a binomial will always be positive. Square of the last term. So therefore, using that short method, square of the first term is x squared twice the product of the first term and the last term, but our first term is x, so where's it? Here, x, and our last term is 6, so x times 6 is 6x times 2, that's 12x. So plus 12x plus square of the last term. Square of 6 is 36. So that's it. Next, our next example, 2x plus 3 times 2x minus 3. Again, as you notice, the first binomial has an opposite operation with the second binomial. Again, we can do it by long method, the FOIL method, and we can do it using the short method. Okay, so FOIL method, I suppose you already know. So let's just use the short method, which is the difference of two squares. I represented it with dots, difference of two squares. Dots is the short method in multiplying a binomial with another binomial having opposite operations. Yan. So difference of two squares, that means you just have to square the first term. So that's 4x squared and square the last term. The last term is 3. The square of 3 is 9. 9. And what is its sign? We mentioned difference here in dots, no? So the sign is negative. It's difference. Okay, so that's it. Notice that the results in our previous activity are in second degree, or the degree of the polynomials are now 2, like say 12x squared minus 15x. So the degree of this polynomial now is 2, which is the result, by the way, of multiplying two linear expressions in one variable. Okay, another. When we multiply a linear expression with another linear expression in one variable, the result becomes second degree polynomial, like 20x squared minus 9x minus 20. Another, x plus 6 quantity squared becomes x squared plus 12x plus 36, which is of second degree. And the last one, in our previous activity, the result is 4x squared minus 9, which is again in the second degree. Now, to wrap it up, these are the left parts of our quadratic equations, which is our next topic, quadratic equations. And now, what is a quadratic equation? A quadratic equation in one variable is of the form ax squared plus bx plus c equals 0. So this is the standard form of our quadratic equations. So all quadratic equations which are not in this form should be transformed into this standard form. So in quadratic equation, ax squared plus bx plus c equals 0, a, b, and c are real numbers and a cannot be equal to 0. Otherwise, if a becomes 0, then the remaining terms become, bx plus c, which is now a linear equation. Now, it is no longer a quadratic equation if a becomes 0. Now, this form of quadratic equation is written in standard form. just like what we have mentioned earlier. In this equation, ax squared, let's just erase this for the meantime. Ax squared is the quadratic term, this one. This is called quadratic term. Dx is the linear term, this one. This is the linear term. And c, this one, is the arithmetic or the constant term. And now, let's consider some illustrative examples involving quadratic equations. We are going to determine if the given equation is quadratic. If yes, identify A and B. By the way, our quadratic equation should always follow the standard form ax squared plus bx plus c equals 0. So as you can see, all the terms are found at the left side of the equation, and at the right side of the equation should only be 0. Okay, so that's what we're going to do on number 1. And you notice that 9 is at the right side of the equation. So all we have to do is we transpose 9 to the left side of the equation so that only 0 will remain at the right side. So it becomes 4x squared minus 2x minus, originally 9 is positive, so it becomes negative now. So minus 9, this is negative, equals 0. Okay, so apparently A is, what is A? This one, no? So the coefficient of the quadratic term, which is 4. And what is B? The coefficient or the numerical coefficient at the linear term, which is negative 2. And C is the constant term or the arithmetic term, which is negative 9. Okay, now let's consider another example. Number 2, x minus 6 times quantity 2x plus 5 equals 3. So we are not sure yet if this is a quadratic equation or not, but we have to do some kind of simplification. So as you can see, we need to multiply two binomials. So do the FOIL method. So that's x times 2x now, which are the first terms. So that's 2x squared. Then the outer terms, x times 5, which is 5x. And the inner terms, negative 6 times 2x, so that's negative 12x. And the last terms, which are negative 6 times positive 5, that's negative 30, is equal to 3. Now, let's do the combination of similar terms. So what are the similar terms here? 2x has no pair. 5x and 12x or negative 12x are similar. So we have to do the operation on their numerical coefficients. 5 and negative 12. So 5 minus 12 becomes negative 7. Oops, we have to change the symbol here because it's negative 7x. And how about negative 30 and 3? So we have to transpose the 3 here to the other side of the equation. Just like what we have mentioned a while ago, that only 0 will remain at the right side of the equation. So 3 will be transposed at the left side. So therefore, negative 30. So negative 30 And since 3 is positive at the right side, and we transpose it at the left side, so it becomes negative 3 now. So it becomes negative 3 here, which is equal, the whole equation is equal to 0. Okay, so we have to do it here. We have to save space. Now, 2x squared, so we will copy it. Minus 7x. And negative 30 minus 3, we can now combine them. Since they are both negative, we will add their absolute values. So that's negative 33 equals 0. Okay, so obviously, we can now identify a at the quadratic term. So this one, a is positive 2, while b is the numerical coefficient at the linear term, which is negative 7, and c is the constant term, which is negative 33. Okay, so it's a quadratic equation. Next, number 3. 3x squared minus 10 equals 3x plus 2 times quantity x minus 2. Again, this is not in the form, or this is not in the standard form. So we have to do some kind of simplification again. So at the left side of the equation, there's nothing to simplify, but at the right side of the equation, we need to multiply 3x plus 2 with x minus 2. Again, do the FOIL method. 3x times x here is, that's 3x squared, and outer terms, 3x times negative 2, that's negative 6x, then 3x, consider the inner terms, so that's 2 times x, that's positive 2x, and consider the last terms, that's 2 times negative 2 is negative 4. Now, maybe we could combine similar terms now. So, as we can see, 3x squared at the left side of the equation is similar to 3x squared at the right side of the equation. So we have to combine them. 3x squared, and we transpose 3x squared at the left side. So minus 3x squared. Then how about 6x? So it becomes positive now because we transpose, and 2x becomes negative now, and 10 will remain, and 4 again is to be transposed at the left side, so it becomes positive 4 equals 0. So what is the final form of the equation now? As you can see, 3x squared minus 3x squared can be cancelled as 0, while 6x minus 2x can be simplified as 4x, and negative 10 plus 4 can be simplified as negative 6 equals, so we have to change the color of this. Okay, so we will change it into this color. 4x minus 6 now equals 0. Okay, now we see that there is no quadratic term in this final answer. Therefore, this is not a quadratic equation, but it is a merely linear equation. So we don't need to identify A, B, and C now. Okay, let's consider another example. Example number 4. So let's multiply 4x minus 7 times quantity x plus 1 equals 2x squared. Again, binomial times another binomial. So do the multiplication of 4x times x becomes 4x squared. Minus, or let's see, 4x times 1, that's positive 4x because they are both positive. So negative 7 times x, that's negative 7x. And negative 7 times positive 1, negative times positive, of course, that's negative 7 is equal to 2x squared. For the meantime, we copy the term at the right side of the equation. Yeah. Now, maybe it's time to combine similar terms. So 4x squared is to be combined with 2x squared, this one, but we need to transpose it again into the left side of the equation. We need to transpose it there, so it will become negative, oops, we have to change the color into a color similar to 4x squared. So that's negative 2x squared. But as you can see, 4x and negative 7x are similar terms also. And to cut it short, you'll just have to do the operation on their numerical coefficients. So 4 minus 7, that's negative 3, and a common variable x, minus 7 is equal to nothing has remained at the right side, so it's 0 now. So we have to do the other solution here. Now, can we combine 4x squared and 2x squared already? Yes, so 4x squared minus 2x squared is simply 2x squared minus 3x. This one, I just copied it because nothing is to be simplified anymore. And same true with negative 7, nothing is to be simplified. So I'll just rewrite it. Negative 7 is equal to 0. And it looks like it already follows the standard form. So we can now easily identify the numerical coefficient at the quadratic term, which is A, positive 2. B is negative 3. And C is, what is our constant term? It's negative 7. So that's it. Okay, next example. 4x minus 5 times quantity 4x plus 5 is equal to 0. As you can see, the two binomials have opposite operations. So on the first binomial, the operation here is negative, and on the second binomial, the operation here is positive or plus, and their terms are the same. So 4x here, the same as 4x on the other binomial, while 5 and also 5 on the other binomial. So to cut the solution short, let's just follow the, oops, it looks like that's B. Let us follow the difference of two squares. Okay, so what is the concept on the difference of two squares again? The square of the first term. So I will erase this for the meantime to show you the process. Okay, so our first terms are both 4x, so we just have to square it. So 16 x squared, and square of the last term. Since our last term is 5, then its square is 25. And what is the operation between these two terms? Of course, it's minus, always minus. Okay, is equal to 0. Now, as you can see, our a, which is found in our quadratic term, is 16, and our b is, do we have a b here? Do we have a linear term in this final answer? We don't have a linear term. That's why our b is 0. And do we have a constant term? Yes, our constant term is this, or include the sign. So I have to erase the other line. Negative. So include the sign. That's negative 25. So therefore, your A is 16, B is 0, and C is negative 25. On my next example, I will show you how to represent the worded problems into symbols involving quadratic equations, or statements, mathematical statements, I should say, involving quadratic equations. Right, let's consider number 1. The length of the rectangular table is 3 feet more than twice its width, and its area is 27 square feet. So we have to represent this into a quadratic equation. Now, as much as possible, your problem should always be represented by a figure, no? By a figure. So, since in the problem, it describes a rectangular table, so we have to draw a rectangle, this one, to represent that rectangular table. Now, of course, the shorter dimension of that rectangular table is its width, and the longer dimension is called its length. Remember that the area of a rectangle, which is also mentioned here, area is 27 square foot, is length times the width. Area of a rectangle is length times width. Now, in solving problems like this, try to observe the condition. So, in this case, the condition is the length, this one, is 3 feet more. More is to be operated by plus, 3 feet more than twice its width. Twice means times 2. So the length is 3 feet more, 3. So in writing expressions like 3 feet more, it's better if you start from behind and going in front. So work backward, right backward, I should say. So 3 feet more, this is the symbol of more, plus twice its width. So 2 times W. The length is, say, the length is represented by equals 3 feet more. So this one, 3 feet more. 3 feet more. So plus ang symbol ng more. Twice times 2 its width. So 2W. Now, by substitution, So area is now equal to length times width, but the length is 2W. So we have to enclose it by parentheses plus 3, that's the length, times the width, which is W. So we'll write the continuation here. So area is equal to, by distribution, W to 2W becomes 2W squared plus W times 3, that's 3W. But the area given is 27 square feet. So again, we can now replace A with 27 is equal to 2W squared plus 3W. Okay, so this is our equation. But so that we can solve for, later on, we can solve for the unknown, we have to transform it into standard form, just like what we have done in our previous activities. Okay, so we have to transpose 27 to the other side of the equation. So I will just have to rewrite 2W plus 3W minus 27 is equal to 0. As you can see, 0 is now at the left side while our terms are at the right side. Actually, we can interchange them. It's just the sense is just the same. So to follow our standard form that our terms are at the left side of the equation, then I'll just have to rewrite the terms 2W plus 3W, or 3 with minus 27 is equal to 0. So now we have successfully represented our problem into a mathematical statement in the form of a quadratic equation. Okay, another example. The length of a car park is 120 meters longer than its width. The area of the car park is 6,400 square meters. So we have to represent this into a mathematical statement involving quadratic equations. Okay, as you can see, it looks like number 1 and number 2 problems are in a way or another common. Okay, so they both involve length. Oops, my L is so large. They all involve length and width, and the area is also given, which is this one, 6,400 square meters. So area is equal to length. It's awkward. Length times width. So, but it is stated in the condition that the length is 120 meters longer than its width. Again, the operation for longer is plus. So the length is 120 meters longer, so plus, than its width. So width plus 120 is equal to the length. So it's 1. Now, since the area is given as 6,000, we have to write it properly. 6,400 square meters. So for the meantime, let's ignore the unit square meters first. Anyway, later on, we will come up with the right unit, because anyway, they have in the problem there are no other units aside from meters. So 6,400 is equal to length, which is represented or to be replaced with W plus 120 times width. So simplify, 6,400 is equal to W times W is W squared. W times 120 is 120 W. Again, we have to transform our equation into standard form. So W squared plus 120 W, and transpose 640 into the other side of the equation. It becomes negative, 6,400, sorry, equals 0. The left side. Again, interchange the terms so that we could obey the standard form. So W squared plus 120 W minus 6,400. We have to conserve space now, is equal to 0. And that's it. We have successfully again transformed our worded problem into a mathematical statement. And that's it for now. Thank you. And abangan nyo ang aking mga susunod na video para matulungan kayo sa inyong module. So please hit that subscribe button below and the notification bell. Maraming salamat!